So we are from Arduino, and we basically are going to tell you a real story, so it's not fake news, but actually how we took almost 6 months to make a migration of all our users from one backend to another without letting them know about that. So, for the users was like, oh, everything is all the same. In the meantime, we had a bunch of developers working full-time in getting everything migrating. So I'm Luca, the CIO of Arduino, and here there is my colleague, Matteo.
Hello.
I'm going to tell you a bit more about Arduino just because maybe not everyone knows about that. But we started as an hardware company, so not going to tell you too much about that. But it started as one of the widely known open source hardware company. And then we figured out that the software was as important as the hardware, obviously. So we started making open source software. So most of our Go libraries are already online. Obviously, we keep learning and improving our software, especially in the Go ecosystem, because the whole company a couple of years ago was using C, C++, Python, Node.js, and many other languages like PHP but I said languages, sorry. So yeah, we started using Go more and more, and we also started to use it as close to the bare metal as possible, even if we have a huge history about using and performing C++ tools, and we cannot just cancel all of them and use something else because we love our users. About our web, because everyone knows about the boards, but the web ecosystem is all made by Go. Go runtime, Go microservices. We have more or less 20 different microservices. We are on top of Kubernetes. And we basically created all our new tools, web tools, especially this Arduino Create web IDE. It's internally made in the backend in Go, and in the front end is AngularJS. So we really love Go. It's been 4 years, I think, now that we are using it, so quite a bit. And at the same time, the team itself started learning Go more and more. So the more we found it stable and production ready, the more we migrated most of our infrastructure to it. Now the story of today. The real story is that we have this web IDE with 650,000 users, so quite a bunch of people. And we wanted to migrate all of them from their actual kind of file system based on S3. So every user has their own sketches, their own files on top of S3, and we had an API to retrieve those files. Obviously, S3 is very nice. It's an object storage. It has really huge latencies. It doesn't come for free. But what was really blocking us was the fact that we had already a lot of tools that were running on desktop machines and were being developed in the last 10 years of history of Arduino, and we wanted to reuse them. Also, in August, we released an open source, the Arduino CLI, the command line tool, and that is based, again, on Go and on file system. So we heavily rely on the file system, while S3 is not a file system, it's an object storage. So we started wondering why we should not reuse what we already done in the past, and we took a business decision to move everything to something that was as similar as possible to our real file system. And that's why today we are starting speaking about interfaces, because we wanted to have the same interface, but a complete different file storage. And here is some numbers. So at that point in time, we had 500,000 users, 12 million files, and almost 130 gigabytes. So it's not really a huge amount of files, but they are extremely tiny. So it's 10 kilobytes per file, more or less, actually even less. That was the real reason for the migration, because S3 is fast if you transfer huge data, but it has extremely high latency. So if you are going to retrieve really a lot of small files, it's going to be super slow. So my colleague Matteo is going to tell you a bit more about the detailed implementation, and then I will come back.
OK, so the first idea we had was a very naive implementation. Let's just stop everything, migrate all the data, deploy the new code that uses EFS, uses the file system, then restart everything. And then run and scramble to solve the issues and retrieve lost data and everything else. It had many issues. For instance, a long downtime without apparent reason for the users. We cannot just say, hey, the software isn't going to work for the next few days. It's bad for business, they tell me. It is
I did.
difficult and long to roll back because you have to do the migration in reverse. And all the users are affected at once. So if there is one error, that error will appear for all the users. And errors are inevitable. So this solution was discarded.
I said no.
We decided instead to do a kind of rolling release, which worked like this. We deploy the code in production, and the code is behaving exactly as before. We migrate a fraction of the user, like for example 1% of the users. We solve the inevitable issues that 1% of the users will encounter. And then, if there are still unmigrated users, go to 2, migrate another batch of users. Repeat until you have migrated all the users. Then you can clean up the code, remove all the references to S3, and you have completed your migration. So how does this work? What are the advantages of this? For example, no downtime. Only a portion of users is affected, so there are a lot less tickets to worry about. There is time to solve errors as soon as they appear. And also you have bragging rights because you managed to do something that it's believed that only giant companies like Google managed to do.
Show us the code.
Yeah. So it's very simple. This is really all there is to it. This is the pseudocode. And if the user has been migrated, then use EFS. Else, use S3.
I am a manager, I can understand this, so it's fine.
Yes. So the implementation of the migrated function was really simple, a Postgres SQL table. We kept track of the migration using this, and that migration call was simply a hit on the database. But where do we go about replacing all the code? In just one of those 20 microservices, we had 26 instances of read file, 27 instances of write file, etc., etc. Replacing all of them is boring, ugly, and also prone to error. So we created a file system interface. Everyone here know what a Go interface is, or someone doesn't know? Cool. Okay, so this file system interface exposes methods that are just like the one that you find in the libraries IOUtil and OS, plus one here that is needed for the migration, and we'll explain it later. So a simple implementation of the S3 file system is just a struct that contains the bucket that we are going to use and the service, the API of S3. And this is the implementation of the read file. The important thing is the signature of the function is the same as the interface. But here you can see it calls the API, it gets the objects, and then it reads the body and returns the data. Instead, the implementation on IFS is even simpler, because underneath it just calls IOUtil read file. So it's just a wrapper around the file system primitives.
But there is an important thing here, the file path.join, right?
Yeah, that's not really important. In our implementation, we use a base to scope the, for example, this disk implementation can write in the folder /webid, for example, and this was the base. So you could have, for example, you could simply say write example.txt, and it will scope it into /webid /example.txt. It was also useful for preventing what's the name? Horizontal path traversal?
Yeah.
Yeah, but that's another story. Okay, so this one instead is the migration implementation. It takes both a file system, an S3 file system, and an EFS file system, and a client. The client is the one that knows about the file system, about the migrations. And it works like this. First, from the file name, get the user. What user are we talking about? We were lucky because in our examples, all files of a certain user were in a certain folder. So from the file name, you could easily extract the user that they belong to. Then we check if the client has a migration, and if the migration was wasn't successful, we will read from S3. Otherwise, we will read from EFS. And this is kind of shift around the same thing as this pseudocode. So really simple. It's just an if. I mean, two ifs, but okay. So how do we use that? Let's say that we have a files controller, which is a struct that will serve files, for example, and in the main, and it accepts a file system interface. Okay? And it works like this. This is the handler. We receive a path, and it will call the read file method of its interface. Here we don't know which file system we are using, but we don't even care. We just want to retrieve the file. And here in the main, when we instantiate the files controller, instead of passing it the S3FS, we pass the migration FS. So inside this read file function, it will look into the database, see if the user has been migrated. If it has been migrated, it uses the new file system. Otherwise, it uses the old file system. And then, well, it returns to JSON and error, stuff like that. So thanks to Go interfaces, we have started the file system. We managed to keep the migration smooth. I mean, it wasn't really smooth because we had to solve the errors, and we found a lot of them. But fortunately, they were very reduced in scope. Only a fraction of users was experiences those errors.
Mainly because with unit testing or something like that, it's extremely hard to really test file systems. Because you cannot prevent, you don't know how are the latencies, so you eventually have to mock up real latencies. You have to understand if the kernel is going to allow you to have the write or the read in the proper time and so forth. So it's extremely hard to test those kind of things. So basically, in general, to test I/O with unit testing or integration testing. what you have to do, and that's the bad thing, is that you have to do on a small portion of your users, see how they perform, and eventually roll back. We likely also have two different environments. One is named like create-dev, where we put everything bleeding edge. And on the other side, we were able to, as I say, migrate just a fraction of users, see how they perform. And usually we do that on our own users. So first thing, we break ourselves. And then if everything goes fine, then we iterate.
Yes, I was saying the first batch of users that you have to migrate is your own users, the users of the development team. And just tell them that you are going to do that, because sometimes you break everything for them and they don't take it handily. So with this, we actually made some mid-migration changes. For example, we changed a lot of how our disk structure worked. We created a new structure called hashdisk with a function named hash that convert a simple file name in a file name with a prefix that is determined from the file name. This way, we managed to spread the files in different directories, and so we didn't have a lot of files in a single directory.
You can't imagine how many users names are themselves like A. So you don't want a file system that is completely unbalanced, no? And if you are going to run a search, it's going to be in this way as linear as possible. So it's completely balanced. It's actually the same things that usually you do on S3 itself. Because if it is unbalanced, you experiment a lot of bad performance. And we are speaking about performance, so that's fine.
So, and this is the implementation of the read file, which is exactly the same as before, just we hash the file name before calling read file. So, to recap, you have to do this, you have to abstract your inner implementation, create common interfaces, try not to change your previous code other than using the new interface, run unit tests, of course. I mean, it goes without saying. But with this, I will prefer integration tests because they are more. They predict more how the data will really behave. Test the interface on a small portion of users and roll out once you are sure of the implementation, and you can go like this.
And the nice thing is now this is in production with really more than 500,000 users. So it's working. We are pretty happy about that. It was hard for us as well because, you know, once you read about interface that are both really criticized in Go and what they really are extremely important in Go by itself, it's very hard to really figure out, especially initially, if you are going to eventually use them other than by an API that someone else did for you. So the nice thing about this is that if later on we want to implement everything that is running on an actual desktop for the user, we can just change again the interface, add another backend, which is going to be the actual file system, and it keeps working. If we want to put that on some other object storage and we respect the same function that were more or less where it is.
Here? No. Here.
Here. So it's read file, write files, make the role, and remove. That's all we need. So no complex feature like handling too much with a permission in some crazy ways. We don't use extended attributes of file systems. This is the bare minimum, but it's extremely simple to implement. So it's really, really, 5 lines of code. I can understand, and I said I am a manager, so it's still good. That was the whole story. Any question?
please.
Yeah. Yeah.
You said something about performance.
Yeah. The performance were really different because now EFS has still high latencies, but much lower than S3. That was really, really good for us, especially for the user more than for us. But that's basically the same. Yeah, so that was a big improvement. The other thing was also that we run something that is named Arduino Builder. That is actually completely open source. You can take a look at it in GitHub. I think it's github.com/arduino/arduino-builder. And the builder does this. So it basically expects all the files in a directory, then launch a bunch of GCC preprocessing, and then gives you a compiled code binary, okay? That was done already and was perfectly working for more than 10 million users. And we wanted to reuse the same component on the backend. So by using ES3, we had better performance. Why? Because we had to copy the whole directory of the user from S3, put them in a temporary directory, compile everything, and then give to the user the binary. While by using EFS, we can compile directly in the same directory without moving the files to another dir. That was a dramatic improvement. The other thing is that with S3, by moving those files, we cannot ever leverage the advantage of having a binary cache. So we cannot cache any incremental changes of their binary, but we had to rebuild every time everything. Well, in this case, by using EFS, if a user wanted to include another library, but the rest of the code is basically the same, we're just recompiling the same libraries. The third advantage is now that we are able to kind of share some of the most used libraries and platform, and if the first user compiles a library, let's say the Ethernet library, for a specific board, this cache can be used by all other users because someone else already precompiled for them. So this is kind of a shared caching system that we are only allowed to do that by using EFS instead of S3.
Sorry, where's your microphone? I don't have one.
I see.
Okay, I just want to add that during the migration, performances were actually worse because for every write we also have to make a read from the database. And that added about a third to the whole response time of the request. So for a long time we had the worst performances, but now we are getting better performances.
Yeah. Any other question? No? Yeah? And we are using Datadog. But that's another story.
During the migration, how did you know that about errors?
Exactly.
How did you monitor the process?
We do use, no, this is not sponsorship, so we pay them. So no, we are actually using the Datadog logger. So we send all the logging of Kubernetes, or any of the Kubernetes microservices to Datadog, and then we query them directly. And that was one big thing. Then the other thing that we did, actually not for the entire time of the migration, but just for a short time, we also had some front-end logging. So we were able to have some metrics. OK, so the user that grant us the access to their telemetry, we were collecting those data and seeing if they were experiencing some front-end errors, like in retrieving data, in creating a new directory, and so forth. We were putting all those data to S3, actually. And with S3, we have our own data lake. Then we process those data, and we extract something. So that was another way. We basically inspect both the backend and the front end at the same time. So in the backend, it was containers provided by Kubernetes, and in the front end was just a console log sent via JSON to S3. And we are actually using something that could be interesting to anyone else. So we spend for about 1 terabyte of data of our data lake, more or less $36 per month, because we use S3 with a CDN in front of it. And if you send a post request to your CDN, you don't have, it's more than serverless. You don't even need a Lambda. But you can send a post request to a CDN, and everything is being logged by the CDN. And you can query your logs, and you have a data lake for $36 a month, which is quite nice. That's the story. Thank you, everyone. And those are our emails. We always keep hiring. If you know Go, much better. If you know PHP, But we still have some legacy applications. So if you want to work on our crap, you are still welcome.
Thank you.
Thank you, everyone.